Okay, where this came from is we're talking about, and when you see this, this will be concatenated with another. I mean, this will immediately follow another video that tells you exactly where this came from. Okay. But the situation is simply we have a, and let me make sure, we have either 50 or 100 gram mass. If the force is 0.2 newtons, it means it was a 100 gram mass at 0.3 meters on a beam. So we have 100 grams right here. And we're applying a force of, well, the force that will accelerate it at 2 meters per second squared. And that force has got to be 0.2 newtons. 0.1 kilogram times 2 meters per second squared gives you 0.2 newtons. Now the torque of that force then, well, this occurs out here at the 3 meter distance, 0.3 meter distance. Force is perpendicular to the moment arm, so that the torque is 0.3 meters times 0.2 newtons, or 0.06 meter newtons. Okay, so here's our torque. Here's the torque that gives us this acceleration. Now we're asked for the same beam to put the same mass at the 20 meter position. So we're going to put another mass, or the same mass, maybe move the mass over, or maybe we're just going to add a mass and find out what added torque is required to accelerate it. Okay, so if this is at 0.2 meters, now it's no longer accelerating at 2 meters per second squared, because it's only 2 meters from the axis. It's not moving as fast. It doesn't have as much acceleration. We can conclude that its acceleration is going to be 2/3 that of the mass at the 30 centimeter position. We could easily conclude that just from this formula. If r is 20 centimeters instead of 30 centimeters, then you're going to get 2/3 of the result for the acceleration that you would get here. But we want to also be sure we understand how to reason it out from here. And the reasoning would be simple. We'd have a 20 centimeter circle here, and everything then would come out 2/3 as much. Okay, so we have the same mass with 2/3 the acceleration, so we're going to have 2/3 the force, or 0.13 bar newtons. Now we could, again, take this 20 centimeters, same angular acceleration. We could figure out all this and come to the same conclusion. That the torque, we still want the torque. Okay, this is our force. It's exerted at the 20 centimeter position, so our torque is going to be 0.2 meters times 0.13 repeating newtons, or 0.02, actually 0.26 repeating, 0.027 meter newtons. So if we have a same mass here, it only takes 2/3 the force, but it's exerted at 2/3 the distance, so you end up with 2/3 the force multiplied by 2/3 the distance. That is 2/3 squared times 0.06 meter newtons, giving you this.